Hi.
Hi, I'm just waiting for some more people to join. I will start
Yeah.
shortly.
Yeah, thank you.
No problem. I see someone asked if it's okay if they record. I am currently recording this workshop and I will be sharing the recording of it afterwards.
But you usually will share it late. I would prefer, if you wouldn't mind, to record it by myself.
Yeah, sorry, that was mostly on my side. I will make sure that GirlCode gets the files pretty much when we're done, and then they can put
Okay.
it up almost immediately. They will be up sooner in the future.
Okay, I don't record, and I will wait for you to share it.
You are more than welcome to record if you feel like it, but there's no
Okay.
need.
Thank you.
No problem. My notes for this workshop, I just shared in the chat, so you guys can follow along the notes if you prefer working off my notes. I'll start at about 10 past. Okay, let's get going. Hi guys, today is workshop 3 of the GirlCode Python workshops. And what we'll be doing today is I'll give you guys an introduction to Numpy, which is a package for Python that is well known for its processing of large data collections. So the first thing we need to do is we need to install the package Numpy, and we're just going to install it through pip, which is Python's package manager. So now you can either open yourself a console, any console will do, or if you're using Visual Studio Code, you can hold in Control and press the tilde key, and then it will open a terminal here for you. And in this terminal, it's the same as where we previously opened PowerShell and used that. This terminal here is just conveniently close. So the reason I'm only introducing this terminal now is because sometimes it has a few bugs and its integration has problems. But you guys know enough by now to figure out whether it's your code or if it's the console just being full of nonsense. So the first thing we do is we type in pip install, and then what we want to install is numpy, so Numpy. And then you just run that command in your terminal. Mine's already installed, so it's not going to install again, but you guys will install from there. Okay, so what Numpy is it's effectively a library for Python. So in Python terminology, it's a module for Python. And what this module does, it is designed to handle large or multidimensional arrays as well as matrices. And then it gives you access to some high-level math functions on these large collections of data. The reason that this is useful is because Python is an interpreted language. Inside of Python, when you have a variable, so I'm just going to create a file so I can show you guys some stuff. Save this file. Cool. So in Python, if you have a variable, whatever your variable name is, so I'm just going to call it var, and you set it equal to a value, what that means is, because Python's interpreted and I can then later go change this variable into a string, and I can do all kinds of different things with this variable, Python allows you to dynamically change the value inside of a variable. Whereas with other statically typed languages, you wouldn't be able to change it. So if a variable is an int, it would be an int always, and if it's a string, it would always be a string. So because Python is so dynamic, there's also the drawback. That means that any variable that you have in Python has to contain the data type of the variable, as well as the value of the variable, and an assortment of other background data that just helps Python keep track of what your variable is and how you change the variable. And that's very useful and very nice if you're programming in Python. But from a performance standpoint, if you're going through a loop, it's going to be somewhat slow. So what Numpy does is it gives us access to basically code that exists in pre-compiled C blocks. So it's C that got compiled into little blocks of code that does functionality for you. These are called universal functions. This is what Numpy calls their functions that they provide that consist of pre-compiled C code. And because it's already compiled code and it doesn't have all this extra data of trying to keep track of something, it's only one specific type of data. That means that it's a lot faster and you're moving your processing from the interpret standpoint into the compiled standpoint. And when you do that, it's orders of magnitude faster. So while you get this very nice fast ability from Numpy, what this also means is that all your Numpy arrays, because Numpy is all about large arrays and large collections of data, whatever your array is, so if it's an int array or a string array or a bool array, whatever's inside of these arrays, it cannot change during runtime. So you can't assign a string into a Numpy array's values if it was an int array. So that's just something to be aware of. But it is significantly faster, which is very nice. So once you've installed Numpy using the pip install, let's start using Numpy. So Numpy is one of those packages that's used so often and so commonly that it's got a default, almost standard convention for how you import the package. So how you import Numpy is you do your standard import, and then you say you want to import Numpy. And when you import Numpy, you import it as MP. And that's just somewhat standard. So if you Google any examples or anything like that, and you put MP in front of it in Python, you'll be able to find some examples, which is nice. Cool. That's misbehaving. Okay, so now we've imported Numpy. Let's quickly write a quick example just to show how Numpy is faster. So it's just for us to see that Numpy is faster, as well as just to see kind of how it works. So what Numpy does is it has these universal functions, as I've mentioned before. And what these universal functions are, they're some of your most common and your most often used arithmetic functions. So that's things like if you want to plus something to an array of data, or you want to divide by something, your whole array, or something like that, then Numpy has a bunch of those predefined for you, as well as a whole host of other functions. So let's say we want to get the reciprocal of a value. So what a reciprocal of a value is, it's basically if your value is x, it's 1 divided by x. That's a reciprocal. So let's say we have an array of values, and we want to get the reciprocals of each one of these values. So the way you go about getting an array of values to work with is you can either go and you can define it manually by hand, or Numpy also provides you the option that it can generate you some random values. So let's just use some of Numpy's random values. So we'll start by going MP, because we're using Numpy's thing, dot random, dot seed, and then we just give it a value. In my case, I'm going to use 0. So the reason we run this Numpy random seed and we define a seed for Numpy is because any random that you do with computers and in programming, it's always a pseudo-random number. So it's not a true random number, and if you define a seed, then every time you call random on it, it will be reproducible if your seed is the same. So we want to run this method a few times and run the app a few times with different code inside of it, but we want the same value so we can make sure that we're consistently correct. So that's why we're defining a seed, so we can always get reproducible random values. So to get an array of random values, we define a variable. I'm going to call our variable values. And then we're going to use the Numpy random dot rand int. So rand int just returns an array of random integers for us. And we want to be using integers, so here we go. Cool. So the properties that go inside of this function call for rand int is the first one is where there's your minimum value. The last one is the second property is your highest number. Then we're going to define the size of this array of values that we want. So we want to be testing the speed of so we're going to be testing the speed at which calculations get performed. So we want a fairly large amount. So you say size is equal to, I'm just going to say 100,000 or 1,000,000, a large number with a bunch of zeros. That value isn't as important, it's just it has to be a large value. So now we've got an array of random values. So what we would normally do in Python is we would define a function that would then return for us a value that is an array with all these, specifically the reciprocals that we want. So let's quickly define that function. So we define a function by saying def, and then we want to just calculate too late. Set row calls. Cool. What this function takes in, is it takes in an array. So I'm just going to call it values. The fact that it's the same as our variable that contains a random int array is purely coincidental. You can have values be anything. That's simply what it is. So what we want to be returning is we just want to return a Numpy array. So what I'm going to do is I'm going to say I want to output. So I want to output, and output is just going to be the name of our variable that we're going to be returning. And what this output is it's going to be, for now, it's going to be an empty array that is the same size as the array that we're putting into it. So if we want to create an empty Numpy array that is the same size as our array that we put in, the way you go about it is you say empty, and that will create an empty Numpy array. It's a function. And then to get the length of this variable that we have, which is an array, I'm simply going to go and say length, which is the function that returns the length of an array. And then I'm going to put our variable in here that is the same as this variable in our function. Cool. So now we've got our output variable, so let's actually calculate the reciprocals. Let's go about that. So for every one of our values in the range of, so doing for every value in the range of the length of the values, that basically just means it's going to do it for every value inside of our thing we want to do a calculation. So then the output value at the index I is going to be equal to 1 divided by, and then our input array, also its index. Cool. And then we actually have to return our output. Cool. So now I've got a function that calculates the reciprocals for all the values that goes inside of an array. Fantastic. Let's actually call this. So I'm just going to make a new variable. I'm going to call it processed. Spelled it out. Processed. My spelling is incorrect. That's okay. Processed values is equal to, and then we want to calculate our reciprocals, and we want to feed it our array full of random ints. Cool. So what this variable will be equal to, it will be equal to the reciprocals of every value inside of this array. Cool. So that is how you would do it in normal standard Python. But because Numpy provides us with these universal functions that are just useful arithmetic, and what these functions do is they, in the compiled C code, go in and perform an action on every single value inside of our array and then return a new array with those values, which is exactly what we're looking for to replicate the behavior of this function. So the way you do it in Numpy, our process values is equal to, and then we say 1 divided by values. So it looks very much like we're just dividing the values here, but what's actually happening is Numpy provided us with this operator, this divide operator that functions on top of an array. So what this is it's a useful wrapper for a function that is actually numpy dot divide and then 1 comma values. That doesn't read as nice, and we are provided with these nice operators, so let's use our nice operator. But this is function equivalent to 1 divided by values, simply because Numpy provided this nice operator for us. Okay, so currently, if we run this code, nothing will happen in our console, and that's because we never actually showing anything in our console. So what we're going to do is we're going to say print, say processed values, and then we're going to go to print, and we're going to go processed values. Cool. So let's run this. So you just saw me click on this little plus here, this little arrow here, and what that is I have the Python extension installed in Visual Studio Code. So that should come with your Visual Studio Code. If it did not, the way you go about getting this extension is you click here on extensions here on the left, and then you type into the search bar Python. You get Python by Microsoft, and you just install and enable your Python. So all that does is it gives you this very nice button here. That what this button does is, if we look here in the terminal, is it refers to our Python installation, and then it refers to our file. So that is functionally equivalent to if I were to go to, let's go here. I were to go and I would open PowerShell, and I type in Python, and then Workshop 3. As you can see, the values are the same. It just all happens inside of Visual Studio Code for us, which is nice. Cool. Okay. My meeting controls goes. Sorry. I just lost the window and it's telling me someone's in the waiting room. It is cool. Okay. So if we look at this, then we see those values look the same, both of them. Those 3 dots in the middle is just it concatenating all the values to be much smaller. It's not going to show us a million values because that's a lot of values to show in the console. So what we've got now is we're doing the exact same thing with 2 different functions. But we don't really know how they performed or which one's fast or anything like that. So let's actually put in a little bit of code that just allows us to actually see how long these things take to process. So what we're going to be using for timing our functions, so we're going to be timing this calculate reciprocals as well as 1 divided by values, which is our Numpy division. We're going to be timing which one takes the longest. And the way we go about that is there's I see someone raise their hand. I don't know what that is. Does someone have a question? Yes. You are welcome to unmute yourself and ask your question if you feel like it. My terminal is not in my directory, you say. How do you mean? You mean this terminal here? Then, okay, cool. So the quickest and easiest way to fix that problem and actually make it refer to your directory is here. If you click File and you go Open Folder, then you select your folder where your files is inside, minus this folder, and then you say Select. So now it here at the bottom refers to the folder where all my code lives. Does that help?
Or add the Python, add the installation directory of the Python to your environment variable.
Okay. So when you installed your Python, there was a tick box that said add Python to your environment variable, but that's okay. Let me quickly get you a solution to your problem, and then we can quickly fix that. Sorry, just give me 1 second. I was hoping there's an easier way, but there isn't. Okay, cool. So to add Python to your environment variables, what we'll be doing is we'll go here, and then we'll go to System Configuration. Okay, no, that has changed in Windows 10. That's fine. What is it in Windows 10? Can I just go? Cool. So Windows 10, you can just type in environment, and it will give you this little window called System Properties with a button here that says Environment Variables. So then you click on Environment Variables, and it will open this. So then at the top one, we'll hit New, and then what we'll do is we'll go to our location that Python is installed, which is generally, if you go to your C drive, if you go to your C drive, and you go to Users, and inside of your Users, you go to your user you are using, and from there, you go to App Data. If you can't see your app data, then your directory is hidden. And if that is the case, let me know, and then I can help you with that as well. And you go to local. Then you go to programs. Then you go to Python. Then your Python install is here. So what you'll do is you'll copy this. And then in your environment variable, your variable name will be Python, and then the variable value will be that. Does that make sense? Yeah, sorry, it's a bit of a weird way to go about it, but it is the way. You can also click on the path option here in your environment variables. And then when you hit edit, you hit new, and then you can just paste in your Python. As you can see, mine is here multiple times. Cool. Cool. If that makes sense and it works for you, awesome. If not, please let me know, and I will show you another way. Cool. Cool. So now that we are here, we are where we're going to be testing the time. So the way we're going to be testing the time these functions take to calculate is there's another very helpful Python package called PyTikTok. So we're going to install PyTikTok, and the way we do that is we go pip install, and then it's pytictoc. And you're going to install that. As you can see, mine's already installed, but yours will download a very small code library and put that at the right place for you. Cool. So let's time our functions. So how PyTikTok works is we go from PyTikTok. We want to import. Cool. So what TikTok does is it has two functions in it called tick and tock. And at tick, it starts a timer, and at tock, it puts that result inside of your console for you. So this is a class that we imported. So with classes, you have to instantiate your class, so create a new instance of your class, as we did with our own classes last workshop. So we're going to go T as our variable name, and then we want to just create a new instance of TikTok. Cool. Now I've got our new instance of TikTok, And then just before we run our calculate the reciprocals function, we want to go t.tick, which will start our timer. It's a function call, so you have your two circular brackets. And then after you called your function, we want to go t.talk. So the talk function has an optional optional parameter, so you can optionally put something inside of the function call, which we are going to do. And what that does is it's pretty much just a prefix for the result that it returns into your console. So we go talk, and then the loop took, just the little string there. So there we go. That's timing our calculate reciprocals loop, and it will then put this and then the time afterwards. And then we want to run another timer for our Numpy values, and then we go t.tick, and then t.talk. And then in this one we go Numpy talk. Cool. So now we've got our timer in place, and we'll just time our two loops and see which one happens fastest. So let's see what happens. Click our little green arrow. If anyone's still having trouble making that work, let me know and I'll help you fix it. Now we see here that the loop took 0.5 seconds and Numpy took significantly less. And while that doesn't look like a lot, we are currently just dividing by 1 on every element in the array. If we start adding a bit more logic to that and start doing stuff like value masks, which I'll cover later in this workshop, and those kind of things, then it gets exponentially longer, which is not great. So there's definitely a lot of value in using Numpy, as we can see simply from the time that it takes to execute the same data. So that's cool to see practically. Okay. So just from a terminology standpoint, these operators from Numpy, they are called vectorized operators. And that just refers to the fact that they don't happen inside of Python, but they actually happen inside of the precompiled arithmetic functions that exist inside of the C side of this. So yeah, it's just a bit of terminology. Okay, so we've now used the divide from Numpy, which then divides by a specific value inside of every element in the array. So the other thing about Numpy is that these operators don't necessarily just work on numbers and values. You can also do it onto lists, to Numpy arrays. You can also do it between multi-dimensional arrays. They apply across multiple different things. So this is one of our operators, and it just divides. Numpy also provides other ones, such as your plus, which is an addition. So that can add a single value to every value inside of an array, or one array to another array, and those kind of things. There's your subtract, which is your minus. So you can minus a specific value from every value inside of your array, or one array from another array. And it does some interesting things with different sized arrays and multidimensional ones, but we'll get to an example of that a little bit later. You can also use the minus as a negative. Then, of course, there is multiply. And then there's a few other ones that are pretty cool. That's your put two multiply or two asterisks, then you are doing exponentials. So you can increase every value inside of value by, I'm now using values as an exponential for 2. So it will give you a new array with the value is exponentially increased by the values inside of value for each element inside of your array. It also works the other way around. You can also have your variable of your array and then do it that way around. And that is obviously the exponent of 2 on every element inside of an array. Cool. Then there's also the mod function, which is just it calculates the remainder of a division and then just returns an array full of the remainders. And then we covered divide, we used divide in our example here. Then there's another one with 2 divide signs, and that is a division floor. So it divides and then floors the value. So if you've got 5 divided by 2, you get 2.5, but it floors that value down to 2. Cool. So that's just covering a few of these other vectorized operators, or things that happen inside of the compiled side of Numpy. And it's just significantly faster than manually looping through and doing it yourself. Okay. So then Numpy, we've covered its random int here. You can obviously do random floats, you can do random and then provide it with a value. It's got a lot of different options with that, as well as there's another function that can return values inside an array for you. So Numpy has got multiple ways of just generating data inside of an array. And one of those is if you go numpy.l in space. Is the way I said it. I don't know if that is correct. I've actually spoken to someone that said that out loud. And what that does is it provides an array of numbers that are evenly spaced over the specified interval. So basically, I can put in a start value and I can say a stop value, and it will give me values that are evenly spaced between those two. And then the third one, the third parameter that goes inside of this function call is the amount of values I want. So I can go array is equal to np dot in space between, let's say, 0 and, so Numpy also has a bunch of constants inside of it. So let's actually use one of those as part of our example. You can go numpy dot pi. Pi, as you guys know, it's just cool to have pi. And then let's say we want 5 values. So now our new array is an array that has values evenly spaced between 0 and pi, and we have 5 values. Let's actually make it just 3 values. Why not? Example. Cool. So now I've got our new array, and we might as well use this new array as part of an example. So the other thing that Numpy does is, because it's providing you with all these basic and most common arithmetic, one of the common arithmetic things that we do is we do trigonometry. So there is your basic sin, cos, and all of those kind of things. But what makes them cool is you can put an array inside of it, and it will return a new array with values inside of it equal to the sin of each one of the values that goes inside of it. So let's actually print this out. So I'm just gonna clean up a little bit so our console doesn't get completely bogged down by a lot of things. So you've got all your normal trigonometry functions. You've got sin, you've got cos, and you've got tan. So let's actually run it. And there you can see. It gives you the sin, the cos, and the tan values of each one of your values that go inside of it. Let's actually also print on array. So you guys can just see that. There you can see 0, 1.5, and 3.141 the pi value. Because it gave us 3 values between these two. It's 0 is the first one, the evenly spaced. The second one is half of pi, and then the third one is pi. So 3 values evenly spaced. Cool. So that's just the basic trigonometry functions that happen inside of Numpy, and that's also calculated all on the precompiled code that lives in C, which is very nice and friendly to us. Okay, so now we've got a basic introduction to Numpy and some of the things it does. We can also then use some of the aggregator values that happens inside of Numpy. So what aggregators are is they are basically an extension that you can run on top of your adds or your adds, your subtracts, your negative, your multipliers, your exponentials, your divisions, all of those kind of things. And then there's two aggregators. There's the reduce and there's the accumulate. And what reduce does is it adds each value to the next value until there's only one value left. Well, not it performs the operator on the next value until there's only one value left. And then accumulate shows you the intermediary values. So what I'm going to do is to just demo those. I'm going to just give us a bit more values to play with there. So on the array, there's now 5 values in it. So these will have our syncros and ton processing on it will give us 5 values instead of just 3. Cool. And then let's actually see one of these aggregators in action. So what we're going to do is we're going to print. We're going to use Numpy. We're going to do an add. And then instead of putting your 2 brackets and then the first value and then your second value that you want to add, we're just going to put a full stop. And we're going to say reduce. And then reduce gets its 2 brackets. And we're going to feed our new array into that reduce there. So then we've got reduce. And then the other one that we have is we've got accumulate. So we go Numpy. I heard add there, not add. Sorry. So let's do the exact same thing. Dot add. But instead of using reduce, we're going to use accumulate. So accumulate. Cool. So we're going to run reduce and we're going to get 1 value back, and we're going to run accumulate and we're going to get an array back that has all the different values. So that's actually just prettier. Reduce, reduced value. So we can actually see in our console what value relates to what, and we're not just looking at chaos. Cool. And then the other one that we're going to be using is we're just going to copy this. Cool. And I'm just going to comment these out. Not have too much code. Cool. So now if we run our code, we get an error. It's trying to add our value to. Okay. So previously we could use plus to just add strings to our print statements, but we can no longer do that because plus now gets overwritten by Numpy. So as you can see here in the error, it says can only concatenate string, not Numpy float 64 to string. So it simply did not know what to do with us because it was trying to add a string into our new value, which made no sense. So yeah, I'm not going to do string concatenation now. I'll cover that when we get to a bit more data heavy things. We want to see more things. So now let's just run it and we'll see 2 values. The first one being reduced and the second one accumulated. Cool. So now we see the first one is 7 0.85, and the second one returns an array, and our array is ending at the same value, but it has the cumulative pluses. Cool. So that's just the aggregators in Numpy, and they are useful if you want to calculate a total of something or something like that, or you want to reduce something to a specific point, and then there's multiple uses that I'm now drawing a blank on. So, cool. So those are just our aggregators. Cool. So the next part of this workshop is going to get pretty cool. What we'll do is we'll actually start using some actual data. So I found another guide for Python that was actually for Jupyter, but it used a data set that was in the MIT license, which means you can use it as long as you give credit. So what we're going to do is we're going to use the Seattle rainfall numbers of 2014. And that CSV file, if you're following in my notes, you'll see there's a link on data. If not, I am pasting it inside of chat. So what you can do is you can just open that link, and that link brings you to a page that looks like this, which looks like absolute chaos. That's completely okay. It's a CSV file, and the CSV file is just comma separated value. That's what CSV stands for. Wait, sorry, I somehow pasted it wrong. There we go. It's now in the chat for everyone. Apologies. So what a CSV file is, it's a file full of values that are separated by commas. And CSV itself stands for comma separated values. So that's just a point of interest. So this is our file that just contains 365 entries. And each one of these entries then contains different information for us regarding the weather in Seattle for 2014. I'm going to use this specific data set a few times going forward, simply because it's a nice collection of values that actually have a bit of meaning to it. So let's right-click anywhere inside your browser. I'm going to say Save As, which will bring up the Save As dialog. And as you can see here, at the bottom with the file name, it says Seattle.csv, Seattle2014.csv.txt. I'm just going to remove the .txt, so we don't need that. And I'm just going to go to the place that my script files live. So when you created your workshop 3 or whatever your file is called, .py, just put it inside of the same folder. Make sure that it's Seattle2014.csv, not .csv.txt. Cool. So we save that file out. And now, if we go and look, we've got that inside the same folder as our script. Cool. So to get the values from this script, there are multiple ways. We've previously used JSON, and JSON is its own data format, similar to how CSV is a data format, JSON is a data format, and you can import the CSV package, and then you can use that to work with your CSV file. But for our purposes, what I'm going to do is I'm going to have us install a package called pandas. And then we're going to use pandas to just extract the values that we want and put it inside of a Numpy array. So as I mentioned before, a Numpy array is an array that has values inside of it that are of a specific type. Sorry, I see someone say they think they saved it as a text file. That's completely okay. What you do is you go to your location where your file is, you right-click on that file, say rename, and then you'll see the file extension there. If you also save this txt, it will read Seattle2014.csv.txt. All you have to do is you just remove that .txt and you hit enter. And now it's a CSV file. You could use it as a .csv.txt. It's just not as neat, and you generally want to have a CSV file as a CSV file. Cool, that should solve your problem. If it does not, please let me know. So as I was saying, a NumPy array has a specific data type inside of it, and that data type cannot be changed. So you cannot assign a string into integer NumPy array. And that's simply because it uses, in the back, as I mentioned, those precompiled functions to quickly perform tasks. Those consist of a statically typed language, in this case C, that has precompiled functions inside of it to do things for us. So if we end up putting that on Python there, it has an error in the back end. So we get an error in the front end from NumPy telling us that we put the wrong thing inside of it. Cool. So we've got, sorry, I got just digressed there. Let me finish the thought. So what we're going to be doing is we're going to be using a package called pandas to just extract us a NumPy array from the CSV file with specific values inside of it. And what pandas is pandas is just a new modern extension library, basically, for NumPy itself. So people saw that NumPy lacked certain functionality, so they expanded what it can do, and that library became known as pandas. And what we're going to be doing with pandas is we're simply going to use it to read in a file and extract the specific values outside of it. In the next workshop, we'll probably be using pandas, and I'll run through exactly what we're doing and how it works, and describe how the data views work and all of those things. And I'll spend a lot of time on pandas, but for this workshop, I'm going to be using NumPy. So what we'll do is we'll just import pandas. I'll put a line of code down and explain to you guys what it does. And then we'll just use that because it is functionality that is useful, and that's going to save us a lot of time instead of importing the CSV package and manually trying to extract the relevant files. So to install pandas, it's the same as installing our other packages. We go to the Python package manager, which is pip, and then we say pip install pandas. Then we run pip install pandas. As you can see, mine's already installed. Yours will quickly install a small package. I believe it's somewhere around 4 megabytes, something like that. Okay. So while that's happening, I'm just going to comment out these. How can you comment multiple lines of code in Python? That is a fantastic question. And the answer is, I am not entirely sure. I forgot. Let me check for you. To comment out multiple lines in Python, it's similar to most of your C-like languages, which is, let me uncomment this and actually show you. And of course, that doesn't work. Cool. Sorry, I found a misleading poster. What you do is you put 3 quotation marks and then 3 quotation marks at the end. Cool, no problem. I lost my meeting controls. Cool. Okay, so that's how you comment multiple lines in Python. To comment out those, we've installed pandas, and now we've installed pandas, and we have our CSV file in the same folder as our Python Workshops 3 file. For the next bit, I simply use Python Workshops 3 as an example of all the different things you can do. So I'm just going to create a new script that we're going to be using to illustrate how to do some heavy data processing inside of Numpy. So I'm going to just create a new file. I'm going to call my new file Numpy data example.py. You're welcome to call your file whatever you like. That is up to you. Cool. So now we've got our new file. We are using Numpy. So we're going to import Numpy as np, as we did before. Apparently my linter program is very anxious. As a syntactic reference, what linter is it's a piece of software that runs inside of your IDE. And in this case, our IDE, our integrated development environment, is Visual Studio Code. And what a linter does is it's a little piece of software that works similar to your interpreter, which is the thing that actually runs your code for Python, where it scans through your code and then it gives you suggestions and changes that it suggests you can make, as well as if it sees you misspell the variable or something like that, it informs you of that. And sometimes you see an underlying thing, that's also your linter at work telling you that you have a problem there. Okay, this is a side bit of digression information. So we've imported Numpy, and now we're also going to import pandas, which is the package I just spoke of, and we just installed using pip. So you import pandas and pandas is also a fairly used package, and it also has a somewhat standard way of importing it. And the way that you import pandas is you import pandas as PD. And went into this very anxious today. Cool. So there we are. We've imported Numpy and we've imported pandas. Fantastic. So now the next step is we're going to use pandas to read in our CSV file, then identify a specific column that we want. In our case, our column is PRCP. Oh, that's right. I'm having some technical difficulties. My screen disconnected HDMI. Give me 1 second. Cool. So PCRP is the one we want, which is our average rainfall. And let's do that. So we have a new variable called rainfall. And our rainfall variable is going to be equal to, and we're going to use pandas. And pandas has a nice function called read underscore CSV. So we've got read CSV, and then what you do is you specify the file you want to read from. In our case, the file we're going to be reading from is called seattle.csv. So I'm going to just rename it and grab its name. So not actually rename it, just copy the text so I can be sure it's exactly that. So we're reading a CSV file called seattle 2014.csv. And then what we want to do is we want to access the PRCP, which is the precipitation. I believe that's what it stands for. Cool. How you do that is so you put the heading that you have, PRCP. So what happens with pandas when you read a CSV, it creates a pandas data view, which I will cover in detail next workshop. It's a little bit out of scope for this one. But then we access the specific column inside of it, which is this one, which I think is either this value or that value. My eyes cannot line up there, but that's okay. So we access a specific column inside of this data. And then what we want is we simply want the values inside of it. what that will do is it will return into the rainfall variable the data that's inside of this CSV file of the specific column, and the values is simply a Numpy array of those values inside of that column. Cool. So that's just quickly using pandas as a shortcut to get the values inside of the file. As I mentioned before, we could have used the CSV module and then manually extracted it, but we wanted the Numpy array, and pandas is the next level we'll get to. Cool. So now we've got the average rainfall in these areas. But because I read the documentation on this data, I know that this data actually exists as 1/10 of a millimeter data. So what we actually want is we want to turn this data into millimeter data. So our millimeters, I can spell it, I cannot spell millimeters. So our millimeters variable, we can turn into our rainfall times 10. So because it's a 1/10 of a millimeter, timing it by 10 will, because this asterisk is the multiply inside of Numpy, so we could have written it as np dot multiply and then have our rainfall and our 10 as our two properties inside of that function. But we've got the nice operators, we might as well use them. So that just turns our 1/10 millimeter into millimeter data. Cool. And then let's confirm that we actually have all of our data and then we've got enough. So what we're going to be printing is our millimeters dot shape. And what that shape is a property of Numpy arrays. And shape is similar to length in other languages. And I could also have put the len function over this variable and gotten the same results. But the shape's just another way to show the amount of entries. So I'm just going to clear my console here, so it's not absolute chaos. And let's run this function. So it ran our function, and we got 365 back. So that means we've got 365 values inside of our millimeters, and seeing as we had 365 days for Seattle rainfall 2014, if we go to the bottom of this file, there's 366 entries because the first one is the headings of each of these columns. So everything looks all right. Cool. Now we've got our values. Now we can start calculating some math on it. So I'm going to take this opportunity to introduce another I'm going to take this opportunity to introduce another component that exists inside of Numpy, and that is the numpy.sum function. And what numpy.sum does is it gives you a summary of the data using specific masked data, basically. So what masked data means is cool. So what masks data refer to is it basically just means that we want to get certain values that fit a certain criteria. So we can do all kinds of logic checks inside of this function that gives us the summary or the amount of things that match a specific condition, a specific criteria. So in our case, let's say we want to know the amount of days that we didn't have rain. So if we want the summary of the amount of days without rain, what we would do is we would go millimeters equal to 0. So back when we did ifs in workshop 1, we checked if something is similar to something using an equals sign. And this uses the exact same logic operator. So it generates a bool of those. It generates an array of bools for each one of the values inside of our array. So if we were to go print millimeters equals 0, what we would get is we would get an array that has 365 values inside of it, and then those values would be either true or false depending on if they met this condition, equals 0. So let's actually do that. Print, and then our summary. So what the summary is it goes in that collection of in that array of bools we have, we now have a check, a summary on it, which means that it's going to add all the true bools together and give us a value back. I see someone posted a question. Hi, sorry, I successfully installed pandas, but when I tried to import it, it returns a module not found error. Okay, so if you, in your terminal, just type in pip install pandas again. What you want to see is that you will see requirement already satisfied for all 5 of the different ones there. If you do that, do you get all 5 requirements already satisfied? Okay, if that does not solve your problem and it does not say requirement already satisfied, let me know and then I will help you debug your problem there. For now, I'm just gonna, while I wait on your response, I'm just gonna run my code here. And then what we see is, we see this array here with true, false, true, false, true, false, whether or not the value in that specific index, the specific element in our array, so the value of that specific index, whether or not it is equals to 0. Then we see a total of those 215 days where it did not rain. Cool. I actually have a cool thing in my notes. This is why it's so useful, where I show an easier way to concatenate things without manually doing it. So what you can do is, you can type this thing, number of days without rain. And then we'll loosely put the plus, and then we got the error. And with Numpy support, we don't have to go and have a specific string concatenation function. And because the plus doesn't work, Numpy provided us with a comma. So now you can go number of days without rain, comma, and then your other value that you want to return. Cool. I see you posted the thing there where it says requirement already satisfied. Cool, so all your things are installed. Okay. Let's see. So it's telling you that your package is successfully installed, but you cannot find your module. Did you spell pandas correctly with a small p? Because it is a case-sensitive thing searching for modules. if you are importing the pandas with the correct capitalization and you are still getting an error, then there are multiple other options. Did you have a problem where your Python was not in your path variable? Because then there's also possibly the thing that it's not aware of where your packages live. So if that is the problem, let me know, and then I can assist you in linking that up as well. So if you were able to use pip, then I'm assuming that Python was already part of your path variable. That's fine. That's something I covered a while back of just making sure that everything knows where everything is. What the path variable is, when someone earlier had the problem where Python was not in that path variable. What the path variable is just a value saved on your Windows sign, where whenever I type Python like that, then Windows knows what to do with it. It tells me you're doing this and this and this. It's referring to Python. And that's because Python is in the path variable. Otherwise, if it wasn't in the path variable, I wouldn't be able to type Python there and get it to give me a result. But just as a bit of information on what the path variable is and why we had to set it for someone that didn't have it there. But if it's just your package giving you an error and you are sure that you are spelling it correctly, that is fairly interesting. Can you please copy me the full error code that you are getting with the module not found? Then that will also direct me to help you debug how that works. Because there's generally a specific error code that refers to where it went wrong looking for this module. You can also paste your code into the chat, and then I will put it straight into mine and see if it's a problem with your code or it's a problem with something else. Let's see. That is really interesting. Import pandas. Check this out. Can you please also send me the code you are using to import pandas? Yeah, so while I wait on you to, there we go. So what I'm going to do is just going to comment mine out. Cool. Let's put yours in, and I missed an I. Cool, your code works perfectly. It is your package that is not installed correctly. I see there where you posted your results from running the pip command again. There's only one requirement.
Can I say something?
Yes,
She's trying to import two library with NP.
Thank you. I am blind. Yes. Thank you very much.
No worries.
Cool. Yeah, sorry if I'm a little bit slow today. I deep in the middle of crunches. We are launching our project, our product list this week. So I've been working very hard for the last few weeks. So if I'm a little bit slow, I do apologize. Okay. So we've got a print number of days without grain. So now using the same masking logic as we have here, let's do some more statistics work. And we want to also print the number of days with rain. And then the number of days with rain is the logical opposite of the number of days without rain. So that would be MP dot the summary. So as you guys saw, this array here of all our bools, what summary does is it just counts the amount of trues and then gives you that value in total. So then our summary is our millimeters not equal to 0. So if our value is equal to 0 is the days without rain, then the ones that are not 0 is the ones with rain. So because our value is in millimeters, if we wanted to then go, how many days do we have more than 5 millimeters of rain? What we would do is go print number of days with more than 5 millimeters of rain. And then the conditional value for that is then millimeters greater than 5. Then if the value inside of millimeters is greater than 5, it will be true, otherwise it will be false, and then summary will give us the summary of that. And then you can get more and more complex, so let's get a bit more complex. Number of days with less than 5 millimeters of rain. The reason I said this one is a bit more complex is simply because if we go to np.sum, what our summary would look like is if we just we want the values with millimeters less than 5, it would also include the zeros. And while true, those days did have less than 5 millimeters of rain, we are still wanting to only see the days where there actually was rain. So how you do multiple of those is you put 2 brackets around this operator, this condition here. We have 2 brackets around it. And then you put an ampersand, and then 2 more brackets where inside you go millimeters is greater than 0. Cool. And that will then give you the days where we had rain, but it was less than 5 millimeters. And this ampersand here, I'm using the ampersand specifically because it's another one of our operators that come with Numpy. Python has built-in comparators called and or. So the difference between and an ampersand, and why you would be using the ampersand here, is and happens between 2 objects, where the ampersand happens for each element inside of our array, just for interest sake why we're using the ampersand there. Cool. So now if we run this script, get our number of days with rain, number of days without rain, the days where we had more than 5 millimeters of rain, the number of days with less than 5 millimeters of rain. Cool. So now we've got this data, but we don't really get a good idea of what our data really represents. So the easiest way to represent data visually is with a graph. And for that, we'll use yet another package. Today, we are just installing all the packages and using them quickly. And then we'll dive deeper into, we'll spend a workshop on each one of these packages that I am talking about today, and properly examine how they work and all the different components of them and how you do complex stuff. It's going to be quite fun. I am excited. Okay, so the library that we're going to be using to plot a graph and just show us a little graph is called matplotlib. And matplotlib is it's very much based on MATLAB, which is a different programming language and a different IDE, basically, that is all about making these graphs. And this library is designed around being familiar and comfortable for those people. And they were made by people that use that language, but also wanted to use that power inside of Python. So what we'll do is we'll go pip install matplotlib. Install that. As you can see, mine's already installed, all my requirements are satisfied. Cool. And then we'll also install another library, which, similar to how Pandas, is based on top of Numpy and just extends the functionality of Numpy, providing it more functions and more functionality without cluttering up Numpy. We've got a package for matplotlib called Seaborn. So you go pip install Seaborn, Seaborn. Cool. So we run that install. As you can see, mine's already installed. Yours might take a minute to install. Cool. Let's install those. So now that we have those packages, so if yours is not yet, it's okay. I will take a minute to explain a few things. So now that we have these packages, we do the standard thing of importing them. And matplotlib is similar to both Numpy and Pandas, as it has a standard import structure. And what that is, you go matplotlib, and then the specific part of matplotlib that we want to be using is called pyplot. So .pyplot. And what that does is it imports the specific, in this case, it is it's a data object that lives inside of matplotlib that we're going to be using. So it's a class because it has functions on it that we're going to be using, and that you import as plt. That is the standard notation for that one. And then Seaborn is the other package we installed, and Seaborn is basically just a nice display package for it. So it comes with templates and color palettes and all kinds of different graphs and things built into it, which just extends the functionality of matplotlib. So let's use that. We go import. We want to import Seaborn. And Seaborn itself, you want to call a function on it called set. And the reason you do that is usually with Seaborn, you'd set your palette and all that, so your app has a specific look and feel to it. You then have a data object that defines these palettes and looks and feels, and then you would feed that to this set function. But in our case, we don't have one, so we're just going to call Seaborn. That's it. Cool. And that also, yeah, as you can see there with the parameters that it exposes there, you can define it in different contexts with different grid styles and all those kind of fonts and those kind of things. Cool. So that's not as important as we just need to remember to set it. Cool. So now we've got our millimeters data, and we know how many there are. Let's, the quick and easy way to just see our data is to put it inside of a histogram. So let's create a histogram, and matplotlib makes it very easy for us. All you do is you go .h, tist, and then you feed it your array. Now it's millimeters. There we go. There's our array inside of the histogram, and then plt.show. So basically, what matplotlib is, there's two ways to interact with it. There's the standard MATLAB way to interact with it, and then there's the object-oriented way of interacting with it. For now, we are using the MATLAB way of interacting with it, which is you just define what you want, and then you say, show me the graph that I've got. I will show you the object-oriented way just after this. The object-oriented way is simply because if we are going to plot a lot of different data, and then I say I have my subgraph 1, I have my subgraph 2, this is what's inside my subgraph 1, this is what's inside my subgraph 2. Once I've defined subgraph 2 using this function style, just define the data, then I can't necessarily go back to my subgraph 1 because I've already defined it and there's no way to refer back to it. So the object-oriented way just allows you to go, this is subgraph 1 as an object, this is subgraph 2 as an object, and so forth and so more. And that's just a way to make it nice and editable and more user-friendly for you. Cool. So now I've got a histogram, run this code, and there we go. Pops up this nice little window. This is Matplotlib's iPlot. They facilitate rendering you a window and all of that. And here is our histogram showing that most of them are 0, almost 300, which matches up with our days without rain. We've got 215. Yeah, everything matches up nicely. My histogram looks weird, but yeah, it is correct. It's probably just a view that you can zoom in and out, and it's got a lot of functionality. Ooh. Cool. So that's a quick introduction to Numpy and installation of a lot of different libraries that we'll be using later on to display all kinds of things and play with all kinds of data. Cool. Is there any questions, concerns, queries before I do a last thing? To make sure we're not losing track of anyone. Cool. Cool. I'm gonna quickly just cover one or two more things. Sorry, I realized my phrasing there was poor. It sounded like I was ending the workshop. Not quite yet. Okay, so we've been using the summary function of Numpy quite a lot to calculate all these values. And the summary variable, the summary makes sense if we're doing all these kind of tests. But if you're doing statistics, then there are some other kinds of values that you want to do, and those are your mediums and your mins and those kind of things. So let's do some medians and some mins. Cool. So with these, you've seen how you can generate an array based on the values inside of another array using one of these checks to see if it matches a certain condition, using your bit masks to generate an array of pools. So, and we've seen how summary works, which is your standard summary as you get in statistics. So there's other things in statistics, and let's use some of them. Sure, sorry, I think I'm double phrasing it. So first thing we're going to do is we're going to create a new variable. We're going to call this variable rainy. And what we want this variable to be is we're effectively going to create an array of pools that we're going to call a mask. So mask is, as I mentioned, conditional applied to an array, and if certain values are met, certain conditions are met, it's true, otherwise false for each one of the elements inside of our array. So if we want an array of every day in the year, saying whether or not it was rainy for that day, what we would do is we would go whether or not it's raining for the day is equal to millimeters, which is the amount of millimeters of rain we had, greater than 0. So those days it was raining. Cool. So now we've got a mask saying whether or not it was raining. But now there's an interesting way we can use this raining. You can go Numpy. Let's speak like this. Numpy median. So that's the median value. So inside of our millimeters, so the median value of our millimeters for the days it was raining. So that then calculates the median value of rainy days inside of every day of the year. We run this. Cool. Then our median is surprisingly broken. Okay, so I think we should just debug our actual values here and confirm what we're working with. Let's do that. Cool. So as you can see here, the values here are very high. Let's see why our values are so high. Oops. We've been timing our rainfall by 10, where we need to divide it by 10 to cancel out our 10th of a millimeter. Now if we run this again, now we have the same values. Cool. Yeah, 19 millimeters of rain sounds a lot better than your 1,913 millimeters of rain. Cool. So yeah, sometimes it's good to print out your data to just actually see what you're working with and know that you are getting the same values. Cool. And if we now look, there we go. So the median of amount of rain that we got over the period of the rainy days is, we got a median of 4.9 millimeters of rain. And let me explain why we can use this mask of rainy. So it creates an array of bools, true or false, if it's more than 0. And then when we apply this square bracket notation to our millimeters, what that means is that it selects the indexes of each one of these that are true inside of millimeters. So then it returns, if we go print numpy.sum of rainy. Let's do this one. Amount of rainy. Oh, we've already got that actually. So there we've got our number of days with rain is 150. So what it does is it selects 150 of the values inside of millimeters. So then millimeters, the value that is inside of median, because of these square brackets, is only 150 values. then calculates the median value of those. So if we calculate the median value of just millimeters, we'll get significantly skewed data because we're also including the days where it did not rain. That's why you create this mask of rainy, and then when you put it inside of square brackets, you are effectively selecting only the days where this array of rainy is true. So if we print rainy, oops, cool. We get this array of true and false, and then by putting the square bracket notation after our Numpy array with rainy inside of it, only these values that are true will be used with the median calculation. Cool. I hope that makes sense. So that is a way to calculate the median of your true values instead of all of the values, because otherwise you're going to get skewed statistics. Cool. Now let's do another one of these masks to clear out specific data for us. So say we want to know the days of summer where it was raining and the maximum of rain we got during summer. We want to calculate both of those. So what we would do is we would go and we create a new empty, sorry, I'm just going to drink some water. We're going to create a new array that we will then check. Okay. Days of the year. I say is equal to Numpy range. And what that does is it gives you a array with a specific amount of things inside of it. So what we want to do is we're going to say 365 because there's 365 days in a year. And then if we want to create a mask for summer to calculate the median rain in summer, what we do is we say our summer mask is equal to I will explain what I'm doing now. Cool. So summer is between the 172nd and the 262nd day of the year. So our mask is between those 2 days. So we've got a mask of summer based on the duration of summer. And the rest of the values inside of this array will then be false, and only the values between this range will be true. So that effectively gives us a mask similar to how we had the rainy mask, but we have a mask with days of summer. So then if we want the median amount of rain during summer, it's very similar to how you get the median amount of rain of your rainy days. So let's do that. During summer. Using Numpy, we want to calculate a median of some kind, and the median we want to calculate is 1 millimeters, but we want to mask the rain amounts to only use summer. So then we put our summer variable inside of the square bracket notation. Cool. So that will give us the median of rain during summer. Cool. So while we're calculating medians, let's calculate another one. Say we want to know the, let's use both our masks, we've got both rainy and summer. We want to know the total median of rain that we got during non-summer rainy days. So let's create a new one. And what we are calculating is the median of rain during non-summer rainy days. Cool. So then we are calculating a median. Using the millimeters, which is the amount of millimeters of rain. So we use our square bracket notation to mask out the values that we're going to be using. And then we want to do it for rainy days. So we go rainy as our rainy variable. And then what we want to do is non-summer days. And as you can see here, we're using summer. And usually if you do the opposite of something, you would put a exclamation mark, but not for masks. For masks, you use a tilde. So if you want the opposite of this mask, you say tilde the mask. Cool. So now we've got the median amount of rain while it is rainy. We've got the medium of rain during summer, and we've got the medium of rain for rainy days that are not in summer. There are other statistics things. Let's just put another one while we're busy. And for this one, let's say the maximum amount of rain we got during summer. Cool. Cool. So the maximum amount of summer works similar to median and similar to sum. We go numpy max, and then we want the maximum of rain we got during summer. So we take our rain amounts, and then we want to use a mask, so we put our square notation, and then we want to get the maximum during summer, so we use our summer mask. Cool. Is there anyone that I lost when I explained how we are generating these masks? Just let me know. I just got concerned there for a moment that I might have lost someone and they're very confused. But cool. So we've got our medians, our maximum, and all our different masks. Let's see this happen. I'm just going to remove that, like that, and we run. Then if we go look in our terminal, number of days with rain is 215, number of days without rain is 215, number of days with rain is 150, totaling 365. So we've got that correct. Number of days with more than 5 minutes of rain is 75. Number of days less is also 75. That's interesting. And then the median amount of rain that we received. I've got a deceiving but that's not the matter. During rainy days was 4.9 millimeters. Median of rain during summer is nothing. The median of rain on non-summer rainy days is 5.1, and the maximum amount of rain that we got during summer is 21.6. So the reason this can be 0 is because it's not for rainy summer days, it's for all of summer, and on the average of summer we got 0. And it's a median, not summer. Cool. That's a little bit of statistics using Numpy. And then we can also, with all these values, we can graph them using matplotlib, and that's what we will be doing next workshop. I'll go all about how do we graph all these different values and show you a few different graphs and how do you communicate with them. That's all I have for today. If there's any questions, concerns, or queries, please let me know and I will advise. Otherwise, we are done for today. Cool. Yes. So uninstall pandas and install pandas specific version. What version of Python are you using, if I might ask? Are you using Python 3 or Python 2? Python 3, okay, cool. I'm just making sure. Some of the packages only work with either Python 3 or version 2, depending on what version of the package you have. And if you have an out-of-date or too new or too old package, then it complicates it. But I'm glad that you're able to figure it out there. Cool. Any questions or comments or anything like that? Cool. And cool. Thank you. I'm glad you enjoyed. Yeah, that's it for today. Thank you very much for attending.